Thank you for attending this week's Data Science Lunch and Learn. I'm incredibly excited about our speaker today. If you read his little bio, he will have said that his biggest claim to fame is that he used the machine learning model to beat Paul the Octopus at predicting soccer scores. Jordan, I tend to disagree with you because there are a lot of big claims to fame with Jordan Tigani, the CEO of MotherDuck. Jordan is one of those amazing engineers, leaders, but also thinkers who work on data, whose work today impacts how we deal with data tomorrow. He's done that when he was at Google, where he was a founding engineer of Google BigQuery, product manager of Google BigQuery, who turned into one of the dominant distributed data warehouses in the world. I had the pleasure of working with Jordan at Single. We worked on a very special high-performing database. He built the software as a service, managed service around that. And I learned a lot from him about data, analytics, databases. And then Jordan seemed to buck the trend and started his own company. And after working on distributed large-scale data problems for many years, he started working on single machine data platforms, embedded database. And it seems to be bucking the trend of everything going wider, scaling.
Not ducking the trend. Oh. I'm ready today.
See, he was ducking the trend.
Oliver, next week, do we get the octopus? Next week, we get the octopus.
I will talk to Michael from Panera and see if he can change the order. They can put some octopus on there.
All right, sorry, Jordan. I couldn't.
Oh, no worries.
Now you know, Dave. Welcome. MotherDuck, company he co-founded, is based on, it's a serverless cloud platform based on the open source DuckDB database, and DuckDB is all the rage. It's getting a lot of attention. MotherDuck is getting a lot of attention. In fact, by last fall, Jordan and team have raised over $100 million from very venerable investors like Amplify, Andreessen Horowitz, and Madrona. So I asked Jordan to come talk to us about his venture, about his ideas, and I want to ask him also to share his thinking about where we are with big data, and where we're going, because I think we can all take away a lot from the opinions of the people who are building the platform of tomorrow. So Jordan, thank you very much for being here with us, and thank you for doing this lunch and learn. Turning it over to you.
Awesome. Well, thank you so much, Oliver. That was a really kind intro that you gave, and appreciate that. So I can skip over my first slide, which is just who the hell am I? I think Oliver did a better job than I could have done. But I have been very fortunate to have gotten a chance to work with Oliver at Single Store, and that was probably the most fun part of that job. There's other maybe less fun parts about that job that happy to share, like in a different scenario. But anyway, so one of the things that I started thinking about was just to okay, I've been working in this area for a long time in big data, but I think the biggest opportunities are where there's something that because you've seen it, but the rest of the world hasn't yet sort of come around to that realization yet. And I think those are sort of where the interesting ideas for startups can be hatched. And I guess hatched, yeah. plenty of duck puns today. But so one of the things is big data is dead, perhaps a little bit sort of overly dramatized in that framing, but just having worked on BigQuery, which deals with big queries and big data, the whole reason I went to Google is because I'm like, Google kind of really gets big data, and they know how to they were way ahead of everybody at the time. But building this giant big data system, we realized that most of our customers didn't actually have that much data. So kind of if you looked at the amount of data that a customer had we had tons and tons and tons of customers that were sort of in the long tail, and really, okay, yeah, maybe there was a couple of people with, these giant enterprises that had petabytes of data total, but lots and lots and lots of people had smaller amounts of data. And in fact, talking to some people in the industry who were data scientists, data analysts, data engineers, and they kind of felt embarrassed. They're like they would go to these data conferences, and somebody would describe how Netflix does their data system, and they would kind of be like, well, am I even really a real data engineer? And it turns out that they were really the majority. And the interesting problems to solve aren't necessarily the scale problems. And I think one of the other kind of the other interesting sides of that is that even when you have a lot of data, it turns out that like by far the most queries and most of the times people use data, they're using kind of the last day of data, but then there's sort of like maybe 7 days of data, 14 days of data. And then, most of the data just sits there. A lot of times people are like, oh yeah, we've got a data warehouse that's got, 100 terabytes. And you kind of ask how they use it. And it's like, oh yeah, well, we've got like 10 years worth of logs. And we pretty much don't touch any of that data, unless maybe we need to go back and sort of restate something from the previous year. So like really, especially like in these, you're building these separation of storage and compute systems, like the fact that you have 100 terabytes of logs is not actually the salient part about the size of your database. Really, the salient part is the hot data. And it turns out that, people end up, the hot data, the data that people, the workloads are way smaller than you would think. Like something like 90% of the queries in BigQuery were sub 100 megabytes. Almost everything was sub 10 gigabytes. And this is something, this is a statistic that I've also heard from Snowflake people. I've heard from other folks as well, that the vast majority of queries over much smaller data. And yet, we're building these sort of giant systems that are designed to handle petabytes. So it sort of made me think that there's got to be an easier way. And so if big data is dead, what do you do? Is, well, you try to make it easy. As opposed to just try to make it giant. Kind of the next big thing is just how much compute power is in a laptop. And for a long time, laptops used to be synonymous with, having kind of underpowered machines that, couldn't really do much. Like you say, oh, you could do that on a laptop, meaning it was sort of a trivial workload. And nowadays, like I've got a 2-year-old Mac M2, and it's incredibly powerful, almost a supercomputer, and is actually more powerful than a lot of servers. And so you have MacBook Pros with 96 gigs of RAM, 16 cores, and they used to be just 1, maybe 2 cores just a decade ago. So yeah, and often, when we're working on cloud applications, working on, doing stuff on the web, are, this incredibly powerful machine is mostly sits there idle. And, I think that's sort of a big opportunity, is how can you make that participate in the computation? Like if you run a query against Snowflake or BigQuery, this super powerful machine on your desktop that you've already paid for, is sitting idle while expensive cloud resources are trying to answer questions for you. And yes, one of the reasons for that is that the data that they're operating on is in the cloud. But if you kind of believe that the data you're operating on isn't enormous, then it can be more effective to do that work locally. So George Fraser, the CEO of Fivetran, if you're not familiar with Fivetran, they're one of the kind of the premier data ingestion and integration vendors. And you know, in his free time, he decided to do some benchmarks, and you know, against various data warehouses, and he benchmarked his laptop, which was a 3-year-old Mac M1, so even older than my laptop. So it was 2 years old, and that was a year ago. Against, you know, cloud data warehouses, and basically, he found that his laptop running DuckDB was faster at, you know, these you know, the TPC H database benchmark than Snowflake, which is, you know, kind of interesting at a lot of data sizes. Obviously, Snowflake could scale as you went up the scale factor size. There were sizes that the laptop couldn't do. But again, those are, you know, hundreds of gigabytes, you know, getting to terabytes. You know, most workloads are not in those ranges. That's, you know, one reason why we say my laptop is faster than your data warehouse. So, you know, the next thing is just so if we have laptops have gotten faster, also servers have gotten enormous. So like back when, you know, the scale out transition started happening, you know, people really stopped building single node systems, was because you know, the servers were actually pretty small. They were, you know, a couple of gigs of RAM and a couple of cores. You know, you could get bigger ones, but they were extremely expensive. And so, you know, it was much more cost effective to just buy a lot of servers. But nowadays, like you know, EC2 instances have hundreds of cores and tens of terabytes of RAM. Like those are huge. Like there are virtually no workloads that will not fit on one of these giant machines. You know, yes, like not every workload can really take advantage of all this, and sometimes there are architectural reasons why, like, you don't have linear scaling in a single machine, but you know, those are all basically fixable problems. So like in, you know, 2010, like the EC2 instance was, you know, basically that you could get was 2 gigs of RAM and 1 core. And you know, now the standard instance is just the basic, like, so when you buy an EC2 machine or an EC2 VM, you know, they're taking a large machine and they're slicing it up into little pieces. The underlying machine is, for the standard instances, is basically 64 cores and a quarter terabyte of RAM, and that is increasing pretty far over time. You know, I was just at a talk by James Hamilton, one of the I think distinguished engineers in AWS, and he's like, yeah, you know, we're on our latest Gravitron, which is their ARM cores. They were putting 192, or, you know, the package in a single CPU package, they're putting 192 cores, which is just a massive amount of hardware in a single package. So there's clearly sort of more ability to sort of to scale up. So you think about, like, okay, if you can scale up, like, do you really need to add the complexity involved in building distributed systems? Oops, thought I had one more slide on this. Oops. But anyway, so like you know, for example, when the Dremel paper came out, so the Dremel is the query engine that, you know, underlies Google BigQuery. The Dremel paper came out in 2009, and you know, the performance it got, you know, running on several thousand nodes was magical. People are like, oh my God, you know, like they can do a table scan in a second. And you basically can get that same amount of performance with a single machine. Or to put it another way, like a Snowflake 3XL, which costs $1 million a year, is, you know, this highly distributed system, but you can get that same amount of hardware in a single server these days. And when you have a single server, like, so when you're building a database, you know, there's a huge cost to building a complex a distributed system. You know, when Oliver and I were at Single Store, like, you know, we were working on you know, distributed two-phase commit for you know, for basically doing distributed database transactions. And you know, it took like 2 years to get that right. And it's like, it's really, really hard. In a single node system, it's just orders of magnitude simpler. Or if you do, you know, joins, you have to do like this shuffle, which is you move all the data across the network. Whereas in a single node system, you just put, you know, you build a hash table and you share a pointer to the hash table. It's just so much simpler. And so you can move faster. You can get more done, and you can innovate much more quickly. The next thing, you know, that people haven't necessarily realized yet, I think people are starting to realize this, is just everybody likes DuckDB. DuckDB has really been just kind of just taking off. So this was a tweet from like when we were just getting started at MotherDuck, and you know, this gentleman was you know, realizing that he could, you know, query over billions of rows in DuckDB. So what is DuckDB? It's this really lightweight in-process analytics engine. You can, if you're familiar with SQLite, you know, SQLite is an embedded in-process transactional database. Transactional databases are good for, you know, single row updates, single row lookups. They're not as good if you want to ask questions about like, hey, who are the top 10 users, or top, you know, who are my best customers, or what things are changing. And so, you know, DuckDB is quite good at that, but it's also incredibly lightweight, can run in the browser, under WebAssembly, runs in process. So it's been, you know, the popularity has been accelerating. This was, you know, even from early 2023. It's now, you know, that line continues. This is, you know, the DB Engines ranking. So database people tend to, you know, religiously follow the database rankings on this. There's a DB Engine site. It's like, where did my favorite database go this last month? And DuckDB sort of continues its, you know, to ascend the charts. So, you know, I mentioned it's embedded, and so how does that work? Also, I just want to mention, you know, if you have any questions, please feel free to stop me as I'm going, and I'm happy to answer as things go. But so an embedded database, so a typical database, you know, is a client and server. An application has some sort of driver. You send SQL to a server, which has an API, computes through your query, and returns your results. And an embedded database, all of the code for the database actually lives inside your application as just it's basically a library that you link in. One of the advantages here is, like in the left-hand side, the application, this driver, is probably ODBC or JDBC technologies that were created in the 80s and 90s. So, you know, somebody was describing the other day as like, is basically your, you know, all of your data, all of your, you know, results have to come through this, you know, 30-year-old straw that, you know, dramatically kind of limits the bandwidth to your data.
So Jordan, for something like that slide there, like on the application you've got, you know, the DuckDB. So is it the typical case going to be, I want to make a manageable file out of this giant database for something I want to look at? Is that mostly what people are doing here, or is there like more analyses and things going on within that when I get to results?
That's a great question. So sometimes, you know, I think sometimes if you're working on something that will fit on your laptop, you download the data locally to your laptop, and you can just operate it on it there very efficiently. It also, like, there's a Python, you know, DuckDB runs in Python, and because it's an application, it has access to the Python namespace. So you can query against a Python data frame, a pandas data frame, directly by just naming that pandas data frame. So there's a bunch of kind of interesting things that you can do. But, you know, stock DuckDB does sort of require, you know, all of the data to fit on your local machine. And when I talk about MotherDuck, I'll talk about how we can expand that to larger data sets.
Thanks.
Sure.
It also runs in R quite well.
Yes, it runs in R. Like dplyr, I think, has been sort of re-platformed to run on to use DuckDB. So I will show a quick demo on DuckDB. Can everybody see this?
The browser.
Yep. So this is the DuckDB web shell. So I mentioned that DuckDB runs, can run in the browser under WebAssembly, and it's pretty tiny. It loads really quickly, and I can run a query that basically is going to pull data from the web. This is doing a join of some like TPCH data, and boom, I get some results back. So it's incredibly versatile. And can you see this one as well, the green screen?
Jordan, may I ask a question? What did you have to do to enable this in your browser? Did you have to install anything?
No, I just go to shell.duckdb.org. It's pretty amazing.
Yeah.
You don't have to download anything. So in this one, I did a brew install DuckDB. So this is basically just stock DuckDB. And I'm gonna go to DuckDB, and then I'm gonna just basically run this same query again. I will actually pull it from here because I should have prepared this one better.
He's not just talking to it, just shows up on.
So the same thing, but this is the DuckDB CLI. I'll come back to the DuckDB CLI in a little bit, but the DuckDB CLI can operate on data locally, on S3, on it's got a really good CSV reader. If you have local databases, also even Excel queries are coming in not too long.
So the URL, sorry, Jordan. So the URL actually is linked to the data set, right?
Yes. So yeah,
If we are working with a local data set, we just replace that with local data file names.
yeah, and
Okay.
actually have so I have those files locally as well. And yeah, super fast, like 1 millisecond.
Wow, thanks.
Sure. Back to. Okay. So, kind of these things that I've kind of described, big data is dead, powerful laptops, enormous servers, and, DuckDB is awesome. Like, what are the things you can do about it? So we built MotherDuck, or we're building MotherDuck, which is essentially doing DuckDB in the cloud as a serverless system. So you send your query off to MotherDuck. We have a DuckDB instance running in the cloud. We spin that up. We can connect to it in 20 milliseconds. You run your query. We can spin it down or keep it cached. We can scale that up. We can scale that up basically to the size of like a Snowflake 3XL, or we can shut it down. We shut it down immediately, so you only pay when it's being queried. So the relationship between DuckDB and MotherDuck. DuckDB is an embedded database. MotherDuck is sort of the if you want to collaborate, because DuckDB kind of only runs is explicitly single player. It runs just on your laptop. If you want to be able to share something with other people, if you want it to run in the cloud, over larger data sets, then you can use MotherDuck. So so what are we doing? The things that we're doing about it. So the first one is we just want to make it easy to use your data. And so I think to a large extent, DuckDB is solving a lot of these problems where of being able to like make the broader problem of I've got a question and I want to get an answer versus I've got a SQL query and I want to get query results. I think the way I think about it is actually most database vendors, they focus on the burger part, like the patty part of the burger. Because that's the part that they can see is like, I get a query and I return results and I want to do that fast. The problem is, there's so many other pieces involved in actually, making a good and effective experience. Like, so one is like, in Python, or R, being able to just run queries directly without having to sort of move data first, or being able to query over your, CSV files without having to do a lot of, data munging and data preparation. In BigQuery, we had like a, new grad work on our CSV parser, and we sort of said, okay, we got our CSV parser done. That's done. Versus, DuckDB, they set out to do the world's best CSV parser. They wrote a research paper about it. They still have an engineer working on it full time, and they keep making these improvements because it has like a, basically a quality of life improvement for people that are actually trying to get work done. I mean, there's so much of the world's data, unfortunately, is still in CSV files. So, one of the ways that we're doing this in MotherDuck is the integration that we have with DuckDB makes it so that, we automatically load when your database name starts with MD:. So, you can use anywhere you use DuckDB, you can start using MotherDuck just by changing the domain name. So we want to basically take the simplicity of DuckDB and extend that, and then all of a sudden, you're running in the cloud. So you might be like, maybe you're prototyping something locally, you're using DuckDB and like, hey, this is great, I'm running this on my laptop. And then you realize, okay, well, now I need to run this. I want to put this in production, or I want to share this with coworkers. How do you do that? And, basically we make it super, super simple. And I'll show a quick demo of MotherDuck.
Jordan, while you set that up, this is one way in which I'm planning and designing to use DuckDB and MotherDuck in the Masters of Data Science courses. I've built databases locally with all the data that they need for the class. And then I serve it up through MotherDuck in the cloud, and the students get a URL, and with that they can access the data, bring the data down. They don't modify the data, and this is one way of making sure everybody has the same data, but I can share gigabytes of data without having to copy them around or send them by email or turn them into CSV files. So as soon as I find an interesting data set I want to use, it goes into DuckDB, maintains a local file, and whenever I want to put it in the cloud, I can do that. It's very flexible and nice to be able to share data through the cloud. Sorry,
Awesome.
Jordan.
Yeah, no, thank you. A customer testimonial, that's the best.
I'm not getting okay.
So this is basically the same query that I was running before, but I have this data loaded into MotherDuck. So we can see we have these, we can get the same results. I'm going to actually just do the join without the aggregation and pull back a bunch of these rows. Over here, you can see one of the things we're doing is, we have this column explorer so that we can basically, you can see, what the values are. You can see the cardinality. You can see how many are, what percentage of the overall values. We can then, this is actually a pivot table. And so we pivot on, for example, market segment. And one of the cool things, and I'll talk about this in a little bit later, is this is actually running DuckDB in the browser. So this pivot table editor is running DuckDB. And each one of these, so when I do this sort, is basically doing a SQL query. And I can, filter by actually nations, the nations, and I can copy this. So filter by. Something screwed up. Oh well. Anyway, I will not show that filter, but so this is MotherDuck in the browser. I also mentioned that you could run DuckDB. So this is just stock DuckDB, from a brew install DuckDB. This is now connected to MotherDuck. And so these are the databases that I have in this, on this right-hand side here that are all in the cloud. And I can run I'll run this same query here. So I can run this query. It runs 147 milliseconds, which isn't bad considering I'm on the West Coast and basically this instance is running on the East Coast. So most of that time is actually being spent traversing the internet. I will show one more thing here, which is this is our code fixit. So we're doing some AI stuff. So basically, if I run this query has a bunch of syntax errors. And oops. I had been testing this out beforehand, and I fixed the syntax errors, but let's break this in a bunch of ways.
I can write you an SQL query. It will guarantee after some errors.
There we go. Let's try this. So I get parser error. So first of all, I was missing a dash. Next one, this FRM, it'll fix that. I can fix that. Must appear in the group by. So adding those to the group by, and then had the wrong format for this stirp time. And then boom, it just runs. So it's kind of nice because it can change the way you actually write your SQL queries, because very often they'll be like, okay, well, how do I do like the date trunk? Is it day with quotes or without quotes? Is it the first parameter or the second parameter? And you sort of type what you think it is, and then it'll just fix it. So it can really kind of keep you in the flow better when you're writing your SQL queries. All right, back to any questions before I go on?
I have a generic question, so not directly related to what you were just showing. So I appreciate kind of the points you're making, but one question I have is when you see companies are not really using all that data and only maybe using the latest data, is part of that maybe because like the tools to make sense out of these very large data sets, or to do that efficiently, or to have the right algorithms that synthesize more important information out of these very large data sets, is simply not available yet, right? So how would this change over time, maybe as better methods or algorithms become available?
So that's a great question. I think that is sort of the way I think people have been thinking about data. I mean, like, so I used to go around the world giving talks about big data and saying like, hey, you can't process all your data yet. Once you can, it's sort of like, it's it's, like, it'll be like you're using like, your whole brain versus, the 14% of your brain that people actually use, which is, itself sort of based on a misunderstanding, but I think like, so for example, Netflix, like basically all of their analysis is done over the last 7 days worth of logs. So basically they want to know what's going on like in the last week. The stuff that's going on last month is not that interesting, and is also like, if you think about like actually having to scan all that data over and over again for years, like it's incredibly inefficient, and there's likely better ways to kind of summarize that information. Yes, you probably want to keep it around so that you can refer back to it, or in case you're like, okay, well, how did we, why did we decide to do this, or how did this happen, like, or how does this year compare, this week compare to last year this week. But that's sort of the that's a lot more rare. Now with AI and machine learning training, you might want to actually do it, do your training at least over larger data sets. So I think that there will still be a need for larger scale data processing for training purposes, but I think that's a different problem than like sort of the everyday analytics problem. Does that make sense?
Sorry, were you done with your questions?
Well, I'm not sure. I'm sure I have another question, but go ahead.
I'm just curious if, say, I was using secure data that couldn't, that had some sensitivity to it, is there, with the collection of information in the cloud system and DuckDB, is there any concerns or protocols that you've set up?
So this is something we are planning on working on. There's a couple of things that we can do. The first one is like, to the extent that we pull data down, basically we're going to encrypt it locally, and with a key that's only stored in memory locally, and you have to fetch on the server each time. So if we did store anything locally, that would not be accessible if like the laptop or something potentially got stolen. Then we also want to be able to sort of mark data sets as they have to stay in the cloud or they have to stay locally. There may be cases where somebody, you don't actually want data to leave someone's laptop and to go into our cloud. And we can do interesting things like we can store the encrypted data in the cloud, but only decrypt it on the laptop, and the decryption key would never leave the laptop. So that's something that we have sort of an intern working on to sort of explore kind of some of these areas of security.
Thanks.
Sure. All right. So then if you're, moving work locally can be interesting, and kind of the way we're choosing to do this is we're building this hybrid execution system, and the hybrid execution system is basically running DuckDB. I kind of hinted at this, and I showed this in the browser, that we're running DuckDB locally as well as in the client. So every time you're using MotherDuck, there's a local copy of DuckDB, including it so if you're using JDBC or ODBC, which kind of traditional ways of connecting to a database, the ODBC driver actually has DuckDB running inside of it. So you can see sort of our overall architecture. You can see the DuckDB logo all over the place. So there's a client-side extension that kind of gives DuckDB the ability to talk to MotherDuck, and then there's a server-side extension which gives DuckDB the ability to talk to our storage. And I'll talk a little bit about what these do. So databases typically go through sort of these multiple phases of in order to execute a query. So first is they parse the query. You take the query and turn it into an abstract syntax tree. You validate that it's actually syntactically correct. Then you bind it. This is where you validate that essentially a type check. You validate it's semantically correct, and you you figure out which tables are involved, what columns, does it match the schema, et cetera, which functions. And then you optimize it, come up with a query plan to run, and then you actually execute it. So so MotherDuck has an extension to DuckDB that kind of intercepts it at all these different phases. So, for example, the parse phase, we intercept it to add some of our own SQL syntax, and then the bind phase is where we will talk to the server to validate that these tables exist and understand the tables, and then we cache all that locally, and then execute. It may have to execute in the server. So the bind phase does recognize the tables where they come from. So if it's a local file, we can recognize that, hey, this is local, and we don't have to actually talk to the server to execute it. What can be interesting is if suppose it's an S3 file, like our server is closer to S3, so we will run that on the server side. Also, there's local DuckDB tables, and then there's remote tables. And so one of the things that we do is we do have a virtual catalog that's cached locally, and so we're able to, for the most part, we only have to do a single network round trip for remote data, and no network round trips for local data. So I will do one more demo to show how hybrid execution works. So what I'm going to do is I'm going to copy the two tables that I was just using. So the nation table and the customer table, and I'm going to run these locally. So this will move from the previous query ran it in the cloud. This runs it locally against local Parquet files, and then I'm going to run it where one of these tables is in the cloud and one of them is actually on the server. So that 155 milliseconds to run this query, and I'll show the I'll show the explain plan for this. So this explain plan describes the query plan of how it actually runs. So one of the things that we can see is we have this download source added, the sort of bridge added to the query, source and sync. So the nation table was running is the smaller table, cardinality 25 versus 15,000. So this is a smaller table, so we download that table. If we had done it the other direction, the large table, we would have uploaded the small table and done the join on the server side. So if you're writing queries, you don't have to know or care where data is. You can just run it. And one of the things that this lets you do is you can build interfaces like this. So this is a 50-line TypeScript application. Most of that 50 lines is in the authentication that uses MotherDuck tables, and this is the FAA flights data set. So let's say you wanted to figure out, you have the hunch that flight delays are, later in the day, flights are more delayed. So this top graph is delay. This second graph is the time of day. This is the hour of day, and this bottom graph is how far the flights are. And so we can just start by saying, okay, well, let's look at sort of in the morning, and then as we kind of go through the day, we can see that this top graph is sort of filling out. So we can see that more delays further in the day. But basically, when I'm dragging this every single pixel that this moves is running a SQL query. So we're running SQL queries at 60 frames per second against data that's in the cloud. And so this just isn't possible with typical architectures because a cloud round trip is going to take 100 milliseconds. And so you can't make things this this interactive. Like here's another example, like, Seattle weather. I live in Seattle. And if you're going to take a trip to Seattle and you want to figure out when is it most sunny, you can kind of like, you scan through here to figure out how sunny it is. And just the cool thing is every single time that this moves, it's doing like a handful of SQL queries to figure this out. And that's sort of what's enabled by the hybrid execution.
So it's not caching results in that kind of GUI
Nope,
interface?
it's not caching results. I mean, it's doing a bunch of clever things with indexing and kind of like, so it doesn't have to do a round trip every time. But a lot of the data gets then pulled back locally so that it can prefetch the stuff that it needs. So I mentioned this scaling up. So oh yeah, this is the one that I was, the slide I was looking at before. This is the kind of the Dremel, basically from the Dremel paper, being able to sort of match that performance with a single instance. And essentially, there's plenty of CPU, there's plenty of RAM, and then storage. There's plenty of storage. The only thing is if it's going to be cold, the network probably isn't fast enough unless you're using one of these fancy TRN instances, and then the network will be fast enough if the data is cold. If the data is not cold and it's cached on local SSDs, then there's easily enough performance on a single node. So I mentioned we're building this sort of scale up system. We're using Kubernetes on the back end, and we will each DuckDB, each MotherDuck user gets a separate DuckDB instance in the cloud. So if you have 1,000 users, so for each one of Oliver's students, if they're using MotherDuck, will get a different DuckDB instance in the cloud that is all kind of independently scalable. So they won't step on each other. And also is one of the reasons that scale up works well is because, one of the reasons that you need a really large Snowflake instance is because you usually have a lot of concurrent usage and a lot of people using the same instance. In this case, we'll basically give everybody their separate instance. So, we're supercharging DuckDB. Life is better with a Duck. And so we've, added DuckDB kind of all over to our architecture to turn it into a true data warehouse. So people say, well, why do I need MotherDuck? Is because there's a lot of pieces in an actual data warehouse that you don't get from just using stock DuckDB. When I was at Google, we used to talk a lot about the sort of the modern data stack as a happy meal, and because the things that people want to do is ingest, and that's data ingestion. That's like the fries, the analysis. That's sort of the core of the meal. That's the burger, and then the visualization. That's like your milkshake. It's sort of the candy on top. And we're adding DuckDB to sort of all of these places, and sort of once you can do that, then it sort of ducks all the way down, and you kind of everything knows how to talk DuckDB. We don't have to move data through these sort of 30-year-old straws, and you can build, like in the visualization side, you can build these really rich user experiences. And so this is actually an older slide of like all of our integrations. We have, I think, 40 integrations now with various tools, open sources, and other vendors, and including a lot of the big ones, but they kind of cover the wide variety of things that people want to do with their data. So that's basically it. What are people analyzing? It's probably not as much data as we would have thought. Mostly recent data, and what do you need to do to make it work? Single machine scale up is pretty powerful, and then because of that, we can build something a lot less complex. and we can move faster, and it can be, you know, a better user experience. And then the power of local, you know, laptops are super powerful. We can do better query planning because we can sort of query, we can plan to use local data versus remote data. So, you know, this is sort of the question that we ask ourselves: how do we take advantage of the imbalance of what people, the conventional wisdom, and what we see is actually happening in the market? And that's it. Thank you. Any questions? Still have a few more minutes.
Yeah, I have a question about, that's related to the analytics program you showed earlier. You mentioned TPCH and these benchmarks. You recently had a very interesting blog about the importance of benchmarking software. Can you give us a 1-minute summary of that?
Yeah, it's, you know, the article was about, you know, that performance is not enough. I think as a database vendor and somebody who's worked on databases, you kind of feel like, hey, if only we're faster than Snowflake, we're gonna beat them. Or if only we can be faster than Cockroach or X, Y, and Z. Or it's like, oh, we're so much faster than this other database. Why are people using that other database? And sort of it turns out that like performance is not actually all that important in getting customers to use your tool, your database. You know, maybe that sounds obvious, but I think when you're sort of in the database bubble, it's like, oh, obviously the fastest database should win. But it turns out that, you know, there's a bunch of other factors, including ease of use, ease of maintainability, you know, connectivity to kind of the types of things that you're doing that end up being a lot more important, and tend to be overlooked by database vendors. And also just, you know, because performance is such a, like, it's hard to say like X database is faster than Y, because it's so dependent on the workload and the specific workload and the things that people are doing. And so, you know, one might be the equivalent of an F-150, and the other one might be a Porsche. Like, there are workloads in which an F-150 is gonna you know, do a lot better than a Porsche, most likely. And you know, either one, if you're stuck in traffic, is gonna take about the same amount of time, and one might be more comfortable. And so you might go with the other one, or one might be more expensive, and you might not want to, you know, or you might not be able to sort of shell out for a Porsche. So yeah, lots of different factors, and that just tends to not be how database people think.
I have another quick question. Please.
Yeah, I'm interested in kind of the relationship between kind of your company and DuckDB. You know, you're building this $100 million, you know, VC funded effort off of an open source kind of framework. You know, what are you like? Yeah, how does that happen, and what is the kind of the interactions that you have with them?
Yeah, so I mean, I think that this is it's a model that can really work well for open source. So when we started the company, we gave the DuckDB folks a co-founder share of the company. So you know, basically to economically align them with what we're doing. You know, they gave us sort of exclusive, like, they're not going to work with anybody else who's doing something similar. They're not going to give the same sort of distribution with somebody who's doing cloud database as a service. And then we pay for basically most of the core development of DuckDB. But they have their own organizations, a services company, and they get to focus on what they love, which is building a great database. And they don't have to worry about, you know, about money. They get significant upside. They don't have to worry about sort of marketing and, you know, all of the stuff that we're trying to do, and sales teams, and, you know, stuff that you need to do to build a big company. They make DuckDB awesome. And you know, I think it helps that they're Dutch. Actually, one is German, but they're sort of Europeans that are sort of like, yeah, I'm not really in this for the money. I want to be able to feed my family, and like, and work on the thing that I love to work on. On the other hand, it would make us extremely uncomfortable if they weren't part of our success if we ended up successful.
So is DuckDB making changes in the database specifically to support MotherDuck?
Yeah, so we don't have to fork. We didn't have to fork DuckDB, and so they put in a pluggable parser so that we could add our own syntax. They put in the virtual catalog, like they it's a pluggable catalog, pluggable storage. Changes in sort of like how their query pipelines work, so that we could download things, and we could do like a select star query over a large table, don't have to pull everything down. There's been a bunch of things that they put in at our request. But they're generally all things that are useful for DuckDB. Some of these things actually have been what allows you to, in DuckDB, to mount a Postgres instance or a MySQL instance, as well as other databases. And so this sort of multi-database thing, which is important for MotherDuck, also works, for DuckDB users.
There's a question here, Jordan.
Yeah,
Sure.
so compared to other big data platform like Spark, Kafka, what's the advantage of MotherDuck? Because it seems like if I don't have big data, I just download it locally, and then I can use SQL or Python just to analyze them. If I have big data, then I can turn to this mature platform. So what's the advantage of your product?
So I have a little trouble hearing you. I think what you asked was if I have small data, why do I need anything except just DuckDB?
The advantage compared to other big data platforms like Hadoop or Spark.
Yeah.
So the advantage compared to other big data platforms, for example, Spark is pretty hard to set up. And you have a controller, and it takes a long time to start running. But I would say 90% of Spark jobs run on a single node, and probably 90% of the rest could run on a single node. DuckDB has a drop-in Spark replacement. So I think it should be relatively easy to switch to using DuckDB instead of Spark, and then it's a lot simpler, easier to manage, and you don't have to sort of deal with this complex distributed system, and chances are it's going to be faster. So I think, but there are still reasons why you may want, you may need to use Spark, for the scale, or there may be things that aren't supported in the DuckDB version.
Yeah, because if I don't have big data, I can just download it locally, and then I can use Python or SQL, just analyze them. So if I have big data, I also have other choices. So why this MotherDuck is unique? It seems like it's integrated. I can directly use Brother, but I may not have that much need to do that.
So I think one of the biggest things is collaboration. So you can download data and operate on it yourself, but then if you want to share the results, if you want to or if the data started getting larger, where emailing around, or sharing sharing CSV files or Parquet files is difficult. And then the advantage over other big data systems that MotherDuck has is I think it's the simplicity, the ease of use, and the cost. So I mean, we haven't talked about pricing, and we don't want to just say, hey, we're the cut rate version of Snowflake, but Snowflake pretty much starts at $1,000 a month, and you can use DuckDB, and you can use MotherDuck for real world workloads for tens of dollars a month. So that can be a big difference for a lot of people.
What made a big difference for me was the hybrid execution, because it really demystifies cloud. If you're comfortable working with a database and the Python interface or interface are great on your laptop, then you can also work in the cloud. And you can, from the same connection, work with data in both. So to your question, when my data really gets larger, as long as I'm not bigger than what I can handle in one of those large instances, I'm using the same interfaces. I don't have to think about here's that barrier where I have to now stand up some other instance, learn another API, learn another, the idiosyncrasies of this versus that. It's all in, sort of in the same platform, it's in the same interfaces. And if it's fast enough, it does the job. That's easy to use, that's great. And so that's, but like when I think about teaching the class, rather than creating this artificial barrier in the class, and okay, up until now, we've been using this, now we gotta go to Spark, or we gotta go to Hadoop, or some other thing, or Databricks. I can stay with what you've already known. I said, yeah, the problems get larger, we just park the data somewhere else and move on and continue in the same vein.
That's true.
And that's very powerful. Jordan, we're a little bit over time. I want to thank you again so much for sharing this hour with us and introducing us to DuckDB, to MotherDuck, and it's been ducking great, and we wish you the ducking best moving forward.
Well, thank you so much. It's great to get the chance to chat with you.